Hi Bobcats. In this video we're going to take a look at the combined gas law. I actually don't really use Boyles Law and Charles Law. In section down the road we're going to pick up Avogadro's law. They're sometimes called the ABC gas laws. I really don't use those. I always just fall back to the combined gas law. So we'll take a look in this segment about how to calculate any one of the parameters, pressure, volume, temperature, when a sample of gas gets changed from one set of conditions to the other. Of course, we have to have numbers for all of the other parameters to make that happen. So the combined gas law basically puts Boyles law and Charles law into a single equation, which says P1 V1 over T1 equals P2 V2 over T2. For operational issues, the units in this equation can be anything for pressure and volume as long as they are the same on both sides of the equation. But temperature is really different. Temperature must be in Kelvin. We cannot use any other unit. If you do Celsius or anything else, you will get the wrong answer on these problems. So some pro tips as we dive into doing these gas law calculations. It's really important that you select the correct equation. If you pick the wrong equation and work all of the numbers perfectly, it's not going to matter because you're going to get the wrong answer. After we do the ideal gas law, I'll show you some tips about how to decide which equation is best to use. Also, I always make a variable list. I've already modeled that in a couple of the earlier videos, and I will continue doing that. And watch out for units. We've got to make sure that we're using the appropriate units no matter which law we're using. And keep in mind, no matter what you're doing, temperature must be in Kelvin when we're doing these gas law calculations. The first example I want to work here is a balloon that's used for underwater salvage is inflated to 50 liters at a depth of 200 feet and a pressure of 6.89 atmospheres and a temperature of 3 degrees Celsius. When you bring that balloon up to the surface, the temperature is 22 degrees C and 0.988 atmospheres. So what will be the new volume of this balloon? Since this problem is going to involve a lot of writing, I went ahead and put this on a separate slide where I've got a lot more room for writing. This is combined gas law, and it says P1 V1 over T1 is equal to P2 V2 over T2. So here is my variable list. These are all of the variables that appear in the problem. And I need to read through the problem and see what I need to do with each one of these numbers. So when we are underwater, the balloon has a volume of 50 liters. And the pressure underwater is 6.89 atmospheres. And the temperature is 3 degrees C, but again, don't stop at 3 degrees C. Add 273 and get 276 Kelvin. Then P2 is going to be up at the surface, and we're told that the pressure is 0.988 atmospheres. The volume at the surface is what we are asked to find, and the temperature at the surface is 22 degrees C, but again, add 273 to that so that we end up at 295 Kelvin. All right, so our combined gas law says P1 V1 over T1 is equal to P2 V2 over T2. And the most common algebra mistake that I see students make has to do with having numbers in the denominator and rearranging the equation. So I would strongly recommend that the first thing you should do on this equation is cross multiply. So cross multiply means that we're going to just consider this to be a great big X. We multiply together everything that's on one branch of the X and set it equal to everything multiplied together on the other branch of the X. So this becomes P1 V1 T2 is equal to T1 P2 V2. And the thing that I am trying to find in here is V2. And V2 at the moment is multiplied by T1 and P1. So to solve this equation for V2, whoops, I left it in green by accident. To solve this for V2, we need to divide both sides of the equation by T1 and P1, because right now they're multiplying times V2. And again, I'm going to flip the equation left to right. And so when I end up doing all of that manipulation, I'm going to have P1 V1 T2 divided by T1 P2. Now I'm going to plug in the numbers, and I'm going to start running out of room, so I am not going to put in units. Notice that our units are okay. Temperature has to be in Kelvin, and both temperatures are in Kelvin. Pressure and volume have to be in the same units on both sides of the equation, but it doesn't matter what those units are. So both of our pressures are in atmospheres. The one volume we have is in liters, and so that means our answer will fall out in liters. So for P1, I'm going to substitute 6.89. For V1, I'm going to have that 50 liters. For T2, I've got to jump down to the bottom, and that's 295 Kelvin. That was the bottom of my variable list. Now for the denominator of our equation, I need T1, which is 276 Kelvin, and P2. P2 is 0.988 atmospheres. All right, so now it's just a matter of running all of those numbers through my calculator. I prefer to do this without parentheses. So for those numbers in the top, I'm just going to multiply them. 6.89 times 50 times 295, and then I have two numbers in the bottom. If I'm doing this with no parentheses, I have to hit divide in front of each, because divide tells the calculator this number's down in the bottom. So I'll hit divide by 276, and then again divide by 0.988. And that gives me a volume for this balloon up at the surface of 373 liters. Something that is very powerful about the combined gas law is that if any one of these variables is held constant, so for instance, the temperature is the same and under the initial set of conditions and under the final set of conditions, it simply falls out of this equation, because if T1 equals T2, you can cancel it out on both sides. We don't even have to know what that number is. That way, I only have to memorize one equation, P1 V1 over T1 equals P2 V2 over T2. I don't have to worry about memorizing Boyles Law and Charles Law, Avogadro's Law, and all of the other laws. I think there's one more, Guy-Lussac's Law. All of that stuff, I just have to remember one. To illustrate this, I'd like to rework the Boyles Law problem from an earlier video, but use the combined gas law to approach it. So the combined gas law tells us P1 V1 over T1 is equal to P2 V2 over T2. And in this problem, it says in the video, the balloon starts with a volume of roughly 2 liters at 760 torr. It's placed in the bell jar, vacuum is pulled, and the volume expands to about 5 liters. So what pressure was achieved in the vacuum system? Well, all of this is happening in the lab. Nothing is being done to change the temperature. So that means that the temperature is constant. We don't know what it is, but we know that it's being held constant because this is just happening in the lab without heating or cooling. So anything that's held constant just cancels out of the equation. So if I get rid of the temperatures, now I'm down to P1 V1 equals P2 V2, which is where we started back in the previous video with Boyles Law. So with just this one equation, you can do a huge variety of problems. Our objective for this video was to use the combined gas law, which is the gas law that we will use when conditions change. You start under one set of conditions and then something happens and you end up at a different set of conditions.